Among triangles, we can separate right triangles as a special case of triangles. A right triangle is a triangle with one of the angles at 90 degrees. The reason we designate right triangles as special is due to a special pattern known as the Pythagorean theorem. A feature common to all triangles is that the sum of all angles is 180 degrees. Because a right triangle has one of the angles at 90 degrees, the other two angles are necessarily less than 90 degrees. Since our 90-degree angle is the largest of the three angles, a side lying across this angle is the longest side. It's called the hypotenuse, marked as C on our graphic. The other two sides are called legs. Back to the Pythagorean theorem pattern. The square of a hypotenuse in a right triangle equals to the sum of squares of its legs, or the other two sides. Looking at our triangle, the hypotenuse C squared equals to the sum of A squared and B squared. The following three dimensions tend to come up on the SAT more frequently than others. Right triangles with sides 5, 4, and 3, 13, 12, and 5, and finally 20, 16, and 12. Since all right triangles have the pattern described in the Pythagorean theorem, we know that there is no right triangle with the sides of 5, 3, and 2, for example. This is so because these dimensions don't fit the pattern. 5 squared 25 doesn't equal the sum of 3 squared, or 9, and 2 squared, or 4. 25 does not equal 13. In the case of three other combinations of sizes, we can see that Pythagorean theorem works. So for example, 5 squared equals to 4 squared plus 3 squared, 16 plus 9 equals 25, 13 squared equals 12 squared plus 5 squared, 169 equals 144 plus 25, and finally 20 squared equals 16 squared plus 12 squared. 400 equals 256 plus 144. Within right triangles, two right triangles are considered to be special. One of them has right angle 90 degrees and then the angles of 30 and 60 degrees. And the other right triangle has obviously the right angle and two 45-degree angles. During the SAT, it would be most helpful to know the pattern of the lengths of the sides of these triangles. In the case of the 60 and 30-degree triangle, right triangle, the following are the dimensions. The shorter of the legs is half the size of the length of the hypotenuse. And the longer of the legs of this right triangle is square root of 3 times larger than the shorter of the legs. The shortest leg lies across the smallest angle, which is 30 degrees, and the longer of the legs is lying across a 60-degree angle. Mathematically, if the shortest leg equals x, then the hypotenuse equals to 2x. And the longer of the two legs equals to x square root of 3. Applying the Pythagorean theorem, what we get is that 4x squared equals to x squared plus 3x squared. So this just confirms the fact that every right triangle fits the Pythagorean theorem and that these dimensions are correct. Let's now consider the right triangle with angles of 90, 45, and 45. Both of the legs in this triangle are equal to each other, and it makes sense considering that they lie across the same angle of 45 degrees. And the hypotenuse is square root of 2 times larger than any of these sides. Mathematically, if the legs have the length of x, then the hypotenuse has the length of x square root of 2. Applying Pythagorean theorem, it works out since squaring of the hypotenuse results in 2x squared, and it equals to the squares of each of the legs, x squared plus x squared. Now that you are familiar with these properties of all right triangles and specifically of the two special right triangles, the best news is that you can find reference to this information on the front page where the instructions are provided for both math sections of the SAT. So you can refresh your memory by referring to that page where it is offered to you during the test.